Hi, I'm Maggie. I'm SQL Server trainer, consultant, and CEO of Inspirit Data Platform Company, which is located in Sofia and Oslo. I'm happy to be here with you today, and I'm happy to be part of SQL Bits 2020. Today, I'm going to talk about SQL Server Table partitioning, and especially those do's and don'ts that we need to consider when we implement the table partitioning in order to gain the maximum benefit of this technology. Table partitioning is not new in SQL Server, but it's rather a technology which has a lot of secrets in implementation. So this I'm about to discover for you today. Table partitioning is an implementation of the universal rule, divide and conquer. When we have a big table and when we have some specific scenarios, we probably would like to divide data in chunks, but this is horizontal partitioning that we reference in SQL Server Table partitioning, and we need to choose a proper partitioning key. Most common partitioning key that we choose is the data time column, and the data time column allows us to divide data in, let's say, months, years, quarters, depending on the usage pattern that we have. Table partitioning gives us a lot of benefits, but we really need to list our requirements, and we really need to assess if our case fits into a table partitioning, because otherwise we risk to just implement yet another technology in SQL Server which probably needs maintenance. It needs to be gathered every day, I would say, and we need to be really careful when we consider implementing a partitioning. So the most common cases of partitioning are basically in the data warehouse, when we have to implement a fast loading and archiving of data. So fast loading and unloading, especially into a table which contains billions of rows, is challenging. And this could be easily implemented and achieved through table partitioning. Deletion of millions of data in SQL Server Table, everybody knows, I guess, is something that takes a while. So it needs to be optimized if we have to delete a lot of rows periodically. The other common case is when we face locking and blocking behavior in our, let's say, a big table in an operational data warehouse, or a mix between operational database and a data warehouse. So in that case, if we have that case, we usually have this different users like readers and writers which use a table at the same time. So once they use more than 5,000 records in a single transaction, or they read more than 1,000 of records in a single select statement in order to prepare their report, then they potentially will escalate the lock to at the table level, which will block the entire table, so the others will not be able to continue their work. So this is a very unlikely behavior of blocking readers and writers. And when we have that case, and when that case is isolated to happen on a big table with a lot of contention in it, then probably we could consider that table for partitioning. So basically those two cases are probably the most common for partitioning, and both could result in optimization of performance, but that could be a beneficial side effect of a good partitioning implementation, I would say. Well, the partitioning has a lot of risk, basically. If we don't consider all the scenarios, if we don't analyze how the table is used, if we don't focus on the queries which use that table, we potentially can have an opposite effect of slowing down the access to the table. So this is basically the critical point of making the decision, should we implement partitioning and how to do that. So I'm going to get back to that part at the end of my presentation, and I'm going to summarize where and how or what you should consider when you think about partitioning and its implementation. So in the partitioning, we have several important concepts, and they make up the whole scenario. So all of them are really important to understand and to consider. Basically, assuming that all of you have some idea of what partitioning function, partitioning schema is, it's just I'm just going briefly through them. So partition function is something that defines the boundaries in your data. So basically, it should have the same data type as our column, partition key column, let's say, or date or integer. And this function creates or plays a critical role because SQL Server needs to understand the partition ID in which the row will be stored. So partition schema is physically dictating the physical implementation, the physical storage of every single record. So in which partition, in which file group that specific record will be stored is defined in the partitioning schema. So we have partition table, of course. So we define the partition table on partition schema. And every single record that we have in that table uses the partition function before insertion, and the partition function returns the partition ID. So the partition ID based on the partition schema will define where exactly the record will be stored physically. So different tables may share common partition functions and partition schema. And here is an example of the objects and how they relate together when we have a partitioning table. So we have partition function, and basically this part of our partitioning architecture, let's say, or implementation, is the partition function. This partition function defines the boundaries. So we have the boundaries, and we have 3 boundaries in this case, because let's say the example says we have to define the partition space by year. So in this case, we have 3 boundaries: the beginning of every year, the first date of every year, and then we have, as a result of that, we have 4 partitions. So I'm using function range right, and that means my first boundary will define the beginning of this partition number 2. Then my second boundary will define the beginning of partition number 3, and my third boundary will define the partition number 4 and its initial value. So the range right defines at which side, I would say, we will have a partition which will gather the data which doesn't fit to any other partitions. So this could be yet another additional partition which stays here at this place, or this will be the partition which stays on the left side of that, but this is actually range right in the function. So every single interval forms a partition ID. So in this case, I have 4 IDs, and this partition ID maps to a partition schema. So the partition schema defines the mapping between the partition ID and the file group. So in this particular case, for every single partition, I will have its file group and the data where the data will be stored. So I'm going to return to range left and range right later in my presentation. But before that, let's see how that looks like as comments and statements in Management Studio. So I'm creating a new database, which is called Demo Data Warehouse. And this database will have several partitions, like the same way that I've shown you in the diagram. So let me create that database first. Here we go. And now I'm ready to implement the partitioning. So again, my first goal will be to create a partition function. So my partition function has an integer as an argument because my table will have a data key as an integer column. And then I'm specifying the 3 boundaries, which will form the 4 intervals in my data warehouse table. Then what do I need to create is the partition schema. So the partition schema will be created for partition for that partition function, and the mapping will go like this. So partition number 1 will map to all the data which are before, which have their data time column or integer column before that value. So then I will map this file group to this first boundary or second interval, and so on and so forth. So I'm creating my partition schema, and then I'm ready to create my fact table. So my fact table, for simplicity, will have just 2 columns: data key, which is my integer column, and of course not null, and a measure, just another integer. The important thing to consider here is I'm creating this on partition schema. So what SQL Server will do in this case? So a SQL Server will do the following. So the insertion of a row will transfer the value of this column, because I said that column will be my partition key, to my function. So my function will assess that value according to the boundaries that it has, and it will return the partition ID to my engine. So my engine, based on the partition schema mapping, will know in which partition, in which file group this value should be stored. So in every file group, I have a habit, which is basically either a B-tree structure or a heap, but the record will be inserted in that specific partition. So back to that part, this actually means SQL Server automatically handles every single insert based on the partition function and the corresponding partition ID and its schema. So I'm inserting different rows, and here we go, back again. So I'm inserting the different rows to my table, in my table, and here is what I got. So I got my data keys, I got my values, and I'm saying that those go to partition number 2, and those 2 go to partition number 3, and this value of 2017 goes to partition number 4. I can use a lot of functions and system catalog tables in order to get the metadata about the partitioning. This is just an example of one of the many for how to get the metadata for a partition table. So this uses the internals allocation unit, system internals allocation unit, and syspartitions joined with the sys file groups in order to see in which file group which partition number is located and how many rows do I have. So as you can see, the first partition is empty basically, and the remaining 3 has their corresponding record. So how we deal with the new data when the new data comes? So when the new data comes, for example, for the year 2018, 19, then we need to basically perform a preparation in advance for getting those data in the proper file group, in the proper schema, in the proper partition. So it's the best way to do that is when we define that boundary before the new data for 2018 will come. And this is actually not just important, but critical when you run your partitioning table into production. So how to prepare in the right way for the new data to come? So first of all, we need to define the file group and the file. So we need to have this file group. And then once we're ready, we need to alter the partition schema first. So we need to specify the next used file group in our partition schema. And here comes the first difference. If you use a range right in your partition function, then your new partition schema will be placed natively to the right in your partition schema list. This is what you expect usually. But if you used a range left, then that will not happen in the same way. So you need to be sure that you understand that, because I understood that by getting a wrong experience. So when you define next use, if you use range left, then this partition will be placed to the left side of the last partition that you use. So this means that a lot of data will be remapped and moved all around between partitions. So that will be really pricey when you have your data already stored into your partition table. So this is the first difference between left and right range. So we prepare that, we define next used, and then we specify the partition function split, and we put the new boundary. So this is our last step. It is really important to not have any data when you perform this step, because if you do have any data which are for 2018, then those data will move around. So they will be moved from this partition physically to the new one. And this could happen while you perform this alter partition function. So here is my example. I'm creating a new file group. Here we go. And of course, I'm creating a new file in that file group. So I am creating a new partition schema. Next use will be file group 2018. Here we go. And now I'm ready to split the function, to add a new interval. And because I'm using a range right, then I will expect to have that interval in the right part of my timeline. So I will split the interval here. And let's see how that will perform in my transaction log of the database. So I don't expect to have any movements of data, because at this point what I have, all my data are for have 2017 as the year. Here we go. So now I have just a couple of records in my transaction log. And if I perform alter partition function like this, and I'm doing split range, then I will check what the effect is to my transaction log file. Here we go. So I got 26 rows for just partition splitting. And what I got here is, you can see that all the transactions that has been performed for this partition split has been implemented, has been performed in the allocation or system tables. So no data has been transferred between partitions. But what if I do that when I do have a data. There we go. So now my new partition is empty, and this was the right time that I created this partitioning, because this splitting of the function, because new data will go to their right partition and to their right direction. So now I got my new data in the correct partition. Here we go. I got my 2 records. What will happen if I have this implemented before splitting of the data? So let me show you what we need to avoid. So let's assume that I will have a new data coming for year 2019 before I create the partition, or before I split the partition, the function for 2019, before creating the boundary. Here we go. So I'm inserting 2 records, and you can see that those records go to the last partition because they are greater than 1st of January 2018. Here we go. So now I got my 4 records here. So then I'm going to create a new file group and to create all those things that I should create before inserting new records. And I'm creating a file. I'm creating the partition schema with next used 2019. And let me show you how it looks like when you split the range with an existing data in it. Here we go. So before that, and here is the split range command. So I got just 3 records in my transaction log. And now, comparing to the first case, where I got 26, now I will get a lot more. Let's say 58. And let me show you what I got here. Okay. So you can see that I have some movements going on into my facts table, and those movements are delete and insert of rows. So I'm deleting 2 rows. Here we go. So 2 deletes from one partition, they go to the other partition, and this is the allocation unit ID. So you can easily check that basically from one partition, which is this, I got this 2 deletes, and I got inserts in my, here we go, insert rows and insert rows to the new partition. So now I got just 2 rows, but imagine that you have a production table with millions of rows. So in this case, it will be really slow. It will take a lot of IO operations to just move data by inserting the new data, inserting the data into the new partition, and deleting the data from the older one. So the general rule here is we never split the partition when we have data in it, when we have data which corresponds to our new interval. So in our particular case, it means we shouldn't create the split here for the year 2018 if we have data already for the year 2018. What to do then? Well, if you still, so one of the do's and don'ts. So we don't split partition if we already have data in it, and we need to plan it carefully. So planning carefully means just do a job or do a schedule in which you create a partitioning, and then you create this file group and everything that is needed, and then you split before the new data come. In case you miss that, which happens quite often, I would say, and it happened in one of our clients actually. So what we did in that case, because they missed to create their new partition for the new year, and what we did, we planned a downtime. So we switch the entire partition out. Then we split data into two tables by using just select into without any deletes. So basically splitting the data into two. And then we use the split partition function to fix the partition function. And then we just merge the partitions, the two tables, into two different partitions. So this is a workaround which requires downtime, depending on the number of records, not that much of a downtime, but still it's not a good idea to do this when you have a data, especially when you have millions of rows in which will be moved around, inserted and deleted. So how do we actually do that? How do we perform insertion and deletion, or let's say loading and archiving data? So what I mentioned in the table partitioning was this was the main benefit of the partitioning. So let's see how we do that. Well, in order to load data, we need to create a staging table. So basically, we can do insert by using insert statement. But if you need to load millions of rows, then you probably will not do an insert statement. You will probably not do a bulk log either, because this means for every record, SQL Server should or has to check the partition function, return the partition ID, and in order to place that record in the proper partition. So this will slow down the load if you have to load or insert multiple rows or many rows, let's say. No matter that if you log the table by using table log like you did when you do, let's say, ETL loading. So in that case, in order to optimize the data load, we prefer to use an intermediate loading table or so-called staging table. The staging table will hold the new data, so before they go to the partition table. So the staging table should have the same structure as the partition table, the same data type, the same column type. We create that table in the same file group where our new partition will be created. Potentially in the latest version of SQL Server, we have an option to perform that in a different file group. So we load values. Let's say I'm doing insert now, but you can do like load by using the different tools for that. And then what is needed, what I need to perform is I need to create a check constraint. So check constraint will ensure SQL Server that all the data that exists into that table fits into the interval of that partition. So my table check constraints will be defined as not null, and I will have a low end and high end partition check constraints. Sorry. Here we go. So I'm defining two check constraints, and then what I'm doing actually is I am switching this table. So I'm generally making this table my partition number 6, which is my partition for the year 2019. Well, let's try to do that. So it's impossible, because in order to perform a switch to the target partition needs to be empty. Well, if you still have data which you would like to preserve, then before switching to, we can just select those data and insert those data into our staging table. So what I try to do with this statement is I'm trying to just get those data which are currently saved into partition number 6 and insert them to my staging table. So I expect to have those two records inserted. Here we go. So now I'm ready to truncate my partition. Number 6, a really cool command that we have in SQL Server. So we can truncate a partition, not an entire table. So I'm truncating the partition, and then I'm switching the partition, switching my table to partition number 6. Here we go. So this load basically is performed in a milliseconds, let's say. So of course, it's actually the fastest way to load the data in the data warehouse. And here is how it looked like at the end. Here we go. So now I got my 7 rows in my partition number 6. How I'm going to archive my partition. So archiving data or deleting data means switching the data out from the partition table and potentially merging the partitions. So yet another important consideration with the partitioning. So in order to switch the data out or to archive the data, what I can do is I can do a staging table at the same way that I did, but this staging table will basically contain my data which I'm removing from my partitioned table. So I'm creating year 2015 archive. It has the same structure. It's created in that file group, which actually contains those obsolete data. And here we go. So what I'm doing here is I'm switching that partition out. So that means I'm getting the data from that partition, I'm deallocating those data or those pages, let's say, and I am allocating them to a new object, which is my table. So this basically means that, here we go. So I'm deleting those data from my table in just a couple of seconds. So now if I run my select against my fact table, prefer to copy paste instead of typing. Here we go. If I run that, you can see that I don't have any data of the year 2015. Here we go. So this is a very fast delete, actually. And on top of that, it's a very fast delete which preserves my data for archiving. So this is basically switching out. So now I got my last partition empty. Here we go. So I basically have the first partition empty. This is the system partition with a range right. The first partition stays here. So on the most left of my table zone. So in that case, I will have my first partition number with 0 rows and my next partition, which I just archived, this partition will be empty as well. So how I'm going to remove that partition? Well, removing a partition happens with the merge option. But again, if we remove the partition, we merge partitions only if our partition is empty. So otherwise, we will again end up with data movement, which is not good. So the drop partition is the one that includes the specified boundary. This is the rule, and the partition is empty. So we need to make sure that we align with this rule. In this case, I'm merging the range of 2015 and I'm saying, here we go. So no movement has been performed. And now I don't have this partition anymore. And my first partition will be, here we go. The numbering goes in this way. And you can see that partition has been renumbered. And my first partition is my system partition. Then my second partition is my 2016. So basically, it's a natural way of, let's say, implementing a sliding window scenario. Again, the partition must be empty and it must be at the end or the leftmost side of my partitioning. So here we come with another important rule or do's and don'ts. Only empty partitions should be removed. So we need to check the partition first. We need to make sure that we empty or truncate partition or switch it out if we want to archive the data. And then a merge will be typically performed after that by using the function. So should we rely on loading and deletion directly to the partition table? Well, better not. So as I showed you, what we usually do is we define the partition switching and we use an intermediate tables in order to perform that really fast. So what I mentioned is several times actually that we have left and right. So range right is probably what I would recommend in every single implementation of partitioning. Range right, especially for dates, natively define the first date. If you implement a range left, then you need to define the last date that is valid for the current partition. So this is a little bit tricky and difficult because it depends on the data type. So you can easily miss a date, you can easily miss a record, and it can easily go to another partition if you don't specify the last possible value that could be valid for that specific partition. On top of that, you already saw that the splitting, it actually depends on the range left and range right because of the order of the place of a new partition in the schema. So what does it mean? Here we go. So just in order to demonstrate you how that works, I've made the same partitioning, but with a range left. And here we go. So what we have is just a little bit simpler scenario with just two partitions, 2016 and 2017. And what I got here is I got my function, and this function uses range left for values. So I'm going to define a new file group, and I'm going to define a new file. So basically this is the preparation for creating a split. And in this case, I'm saying that I will use, the next use file group in the partition schema will be 2018. Well, okay, and I will expect that to go at the right in my partition schema, at the right side, rightmost side in my partition schema. So if I run that, and if I say, okay, now let's split that, then you will see, here we go, this is the splitting, and I still don't have any data of 2019 actually. So I'm just creating a new partition according to the rules. But what happened behind the scene is actually a lot of movement. So you will see that this movement indeed happens between partitions. Here we go. So you can see that my partition table has experienced a lot of insertion and deletion. And why is that? Well, let me show you. If I go and try to script my partition schema, no tables, but programmatically. Oops, oh my God, I got a little bit of luck here. And schemas, here we go. And this is my schema. So I'm going to script it, and you can see, here we go. Yep. So this is the whole reason of data movement when we use left range left. So range left means, on top of all the other things that I mentioned, range left means that the file group, the next used, will be placed on the left side of the partition which stays close to it. So in this particular case, this means that the mapping will be corrected. The mapping will be changed, which will force the data movement. So the mapping will be changed because the partitions, well, the partition function should map to the partition schema. And if I change the mapping and if I reinsert a new file group in between, and I'm saying that this file group will stay here, then the mapping will change. And this potentially will be the reason of movement of data. So basically that means all the data will be moved from my file group here to my file group here. So pay attention to this and potentially never use range left actually. So it creates more problems and it's something that could create your performance issues as well. So finally, what about the performance? So just a few words about that. So I'm going to create a cluster index. You can create it in the very beginning of your table creation. So basically the cluster index is created on at least the leading column of the cluster index should be the partition key. So I'm creating the cluster index on the data key. And let's see some execution plans, really simple execution plans. So I'm switching to the actual execution plan. And if I run that query, which has a where clause of the data key column, so I will expect SQL Server to be able to identify in which partitions my records are located and to force my operation to only those partitions. So I will see that into my execution plan. And if you can see the execution plan here, then you can see that the partitioning has been recognized and the actual partition count is 1. Well, that sounds promising, so I'm not scanning all the partition. But what if I use another column, not a data key, in my where clause? Well, that will hurt. And this is because SQL Server doesn't have any chances to understand in which partition my record resides. So in this case, I'm going to scan all the partitions. Here we go. So when we create a partitioning, we need to make sure that we analyze all the queries that we send to that table. And all those queries should have a partition ID, or let's say not partition ID, the partitioning key column in their where clause in order to get the real benefit of the partitioning and dividing data in chunks. So you don't want to divide data in chunks and then to scan all the entire table. So that should not happen. And in this case, we probably need to, let's say, create an index, which should be an additional one, which could be created in the primary, let's say, file group. And this index could potentially gives us a hint on where the specific data column resides. Here is the final example of that. So I'm adding just a new column, just to have 2 columns. And I'm saying that, okay, I need to query some data, but my where clause still stays as a measure equals to something. So in this case, it's clear that I'm going to scan the entire table. So what to do in order to avoid that? Well, I can do a non-cluster index, and that non-cluster index could be performed on primary or on the partition schema. If I perform that index on the partition schema, then that index will be aligned to my partitions. But probably it's not something that I would like to have here because I don't have this data column in my where clause. So I need to have a mapping between all those measures and their corresponding data column. So if I'm able to find that data column value, then I will go through the partitioning to the corresponding partition that I'm looking for. So let me try that. Here we go. So this is my non-cluster index, which is not aligned to my partitioning. And if I run that query now, and if I get my execution plan, then you will see that an execution plan is just a seek operation. So the first thing that it does, it gets the measure, the table measure, and then it goes to my table, to the key lookup. Here we go. And it gets the data key. So basically, based on the data key, it goes and gets my record from the corresponding partition. So just to mention that creating a non-aligned index is something that will not fit to the switching in and switching out scenario. So we need to be aware of that before implementing partitioning, and this comes as the last point in my do's and don'ts. Thank you. Waiting for your questions.